Hello, my dear student. I'm Mr. Kitwala from Educare.tz. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our session, as you can see here. So, on our discussion, my dear student, we are going to proceed with our subtopic of the physical quantities. The way we was ended on the last period, now it is a time to proceed with our second sessions. So, my dear student, I ensure that there are something you regain for these sessions. So, welcome for this session, my dear student. And today we are going to see about the dimensional analysis. How can we obtain the dimensional analysis? First of all, my dear student, let us go and see the definition of the dimensions. And after there, we go and focus on how the dimensional analysis can be defined. Because on your examination, you will be asked to define the dimensional analysis. So when we talk about the dimension, my dear student, these are the powers of the fundamental quantity that represent a certain physical quantities. The power of a certain fundamental quantities that represent a certain physical quantity, which say we can take it as the dimensions. Inside the dimension, my dear student, we have the fundamental quantities. And these fundamental quantities that are found in the dimensions are usually to represent the physical quantities. For instance, we have the mass. Now, we are supposed to go and find the dimension of mass, the EP. That is how can we define about the dimensions. But as you can see here, our definition starts with the powers. It means the exponents. Those dimensions will involve some powers or will involve some exponents. We'll go and see, my dear students. As I told you, we have either the fundamental quantity, either we have the mass, or if we have either the derivative quantities. Those derivative quantity, we are supposed to simplify it so as to get the fundamental quantities. Na baada ya kupata zile fundamental quantities, we go and find the dimensions that can be expressed in a powers form. As you can see here, it can be represented by square bracket. What is the symbol that represents the dimensions? This is some question that will be asked through your examinations. That can you give the symbol that represents the dimensions? That you can answer this question by saying that the dimension, my dear student, can be represented using the square bracket. But its symbol is like this one. Tunatumia hizi scala, easy square brackets for aims of expressing the dimensions. Finally, my dear student, let us go and look about the dimensional analysis. After getting the concept or the overview of the dimensions, now it is a time to see how can we define the dimensional analysis. As you can see here, when we talk about the dimensional analysis, my dear student, this is the method of establishing a relationship among the physical quantity using the basic quantities. The method or the process of establishing the relationship between the physical quantities using the basic quantities, we term it as the dimensional analysis. Kwa kile kitendo cha kuweza au ile njia ya kuweza kuhusisha, kuweza kuestablish, kuweza kutengeneza uhusiano uliopo kati ya zile physical quantities tunaita ni dimensional analysis. Here always we use the basic physical quantities, the basic fundamental quantities ambao tunazisema ni mass, length pamoja na times. Japo na zile derived quantities zinakuwa zinatumika, lakini we are supposed to express it in form of the fundamental quantities. So my dear student, this is on how you can define the fundamental, the dimensional analysis. But you are not allowed, my dear student, to claim. You have to understand that we use this dimensional analysis for the aims of establishing the relationship between the physical quantities. Sasa tuna physical quantity zetu, either we have the mass, we have length, we have the time, we have the temperature. How this physical quantity can be related? That is the focus of the dimensional analysis. So as you can see here, that any physical meaning equation, we have the same dimension on the left and the right sides. This dimension, my dear student, can appear in two sides. It can appear on the right side and also on the left sides. And there is the condition that we are going to see, my dear student, on how we can prove that this is dimensionally correct. It means that the dimension that are found on the left side must be the same with the dimension that are found on the right sides. Kwa hapa zile dimension zinakuwa zinapatikana kwenye zile physical quantities zako, either zilizopo at the left side and also on the right sides. We'll go and see how this, my dear student, can appear. But we always ensure that, my dear student, the dimension of the quantity that are found on the right side must be the same with the dimension that are found on the right side for those the quantities. So on how you can explain about the dimensional analysis. Therefore, we can conclude by saying that dimensional analysis is important for checking the correctness of the formula and establishing the relationship among the physical quantities. Why we learn the dimensional analysis? This is the question that you can be asked. Kwa nini unajifunza hizi dimensional analysis? Why we learn this dimensional analysis? You have to ask yourself, my dear student, because tumejaribu kuona definition of the dimensional analysis. Now there are some things that we have gained about our definition. Now it is a task for you to ask yourself that why we learn this dimensional analysis. So we learn this dimensional analysis because it is very important for checking the correctness of the formula and establishing the relationship among the physical quantities. Kwa hii hapa tunakuwa tunajifunza kwa lengo la kuweza kucheck, kuweza kuangalia the correctness of the formula. Je, ile formula yetu iliyoandikwa pale iko sahihi? Kwa tuna apply zile dimensional analysis ili tuweze kuangalia ile correctness, usahihi wa ile formula. We have the formula of the pressure, ambapo tumeona pressure is equal to force per unit area. Now you can use the dimensional analysis so as to check if the formula of the pressure is correct. Kwa tutaweza kutumia hivyo ili kuweza kuangalia, je, ile formula yetu iko sahihi? Na kama haiko sahihi, how can you conclude? How can you establish the relationship among the other physical quantities? Baada ya kuweza kuangalia, kucheck the correctness. Now sometimes we use this dimensional analysis so as to establish the relationship among the physical quantities. Also, my dear student, as you can see here, this is the importance of the dimensional analysis. You have to understand it. So the table below shows the unity and dimension of some common physical quantities. Now here, my dear student, we are going to see the table that explains about the dimensional analysis. We have the physical quantities and also the dimension of those quantities. Twende tukaangalie how can we express those physical quantity in a dimension form. How can we establish the relationship between the physical quantities? How can we check the correctness of the formula for the quantity that you will be given? Here it is our table, my dear student, that explain about the dimensional analysis. On our table, my dear student, we have our quantities. And on this quantity, my dear student, there is the fundamental quantity and also the derived quantities. But we simplify those derived quantity so as to get the fundamental quantity, and that can give us the dimensions. For instance, at the first law, we have the mass. The unit of mass we know is a kilogram. Now, what is the dimension of mass? You will be asked to find the dimension of mass. Ni ngapi? Kwa tunachofanya, tuna introduce the curly bracket. Baada hapo, tuta express kwamba dimension ya mass itakuwa ni m, kama tunavyo observe here. This is the dimension of mass. Also, we have the length. Length, the unit of length is meter. Here there is no any any problem. Kwenye hizi unit hazina shida. Shida ipo kwenye kutafuta hizi dimensions. So my dear student, the dimension of length is L. Kwa kule ukiambia kuweza kutafuta ile dimension of length, utamwandikia, utaiweka ile length. It means hapo utaiwekea ile squared bracket. Baada hapo utaweka is equal to L. Lakini we have also the time. The time, it is the unit of the time is second, my dear student. It is not the problem, but the problem can occur on the dimensions. How can we get the dimension of the physical quantities? So the dimension of time, my dear student, will be t. Itakuwa ni t, though itasimama kama dimension of the time. But also we have the velocity. This velocity, my dear student, we know that according to the definition we learned on form 2, we said that the velocity can be obtained by taking the displacement per unit time. Ndio maana hapa tumeona the unit of velocity is meter per second. Hii tumeweka ni meter s power -1, lakini hii hapa ni meter per second because this second is iko chini, is below. Kwa tunachokifanya tunaipandisha juu, inakuwa na negative hapo, inakuwa ni s negative, ni meter per second. How can we express the dimension of the velocity? The dimension of the velocity, my dear student, can be obtained using the formula of the velocity ambao ni length per unit time. Kwa itakuwa tutatumia ile dimension ya length ambao ni L, it means per unit time. Time is below, iko chini. Kwa tutampandisha juu alafu atakuwa ni LT power -1 kama tunavyo observe pale. But the acceleration, my dear student, is also within on form 2. Tulisema yenyewe inapatikana kwa kuchukua the change of the velocity per unit time. If we want to obtain the dimension of the acceleration, we are supposed to simplify the formula of getting the acceleration, and after there we will find the dimensions. Kwamba ukiangalia mle ndani ya acceleration we have the length per unit second per unit time square. Ndio maana hapa utakuja utatumia ni L na T power -2. That is the dimension of the length of the accelerations according to the formula. Kwa unachotakiwa badilisha zile derived quantities zipeleke kwenye fundamental quantity, na baada hapo uweze kuzisimplify kutafutia zile dimension zake. Also we have the force. This force, my dear student, it is unit is Newton, it is Newton. Lakini inside the Newton there is the mass which is called it means the kilogram. 1 kilogram, and also we have 1 meter. Also we have 1 second square. Because we obtain the force by taking the mass times the acceleration. Now we know the dimension of the mass. Kwa tunachotakiwa tuweze kutafutia kila dimensions ya zile quantity zako ulizonazo. Kwa we will use we will find the dimension of the mass and also the dimension of the acceleration ambayo tulipata hapa juu ni LT power -2. Kwa tutaintroduce pale ni mass LT power -2. This is how you can express the dimension of the length of the force. Also we have the density. We obtain the dimension of the density. First of all, let us consider the formula of the density. Density is equal to mass per unit volume, but volume is equal to L cube, length times length times length. It means if we find the dimension of those lengths, of those quantities that are found inside found inside the density, we'll get equals to mL power -3. So this is how you can identify the dimensions of the physical quantities, my dear student. So after there, my dear student, after getting the dimension, you have to think, you have to yourself, you can use this concept to find the dimension of the other quantities. Either find the dimension of the pressure. Unaweza kutafuta dimension ya pressure. Also the dimension of the area. You try to find the dimension of the other quantity are not mentioned here. So after there, we have an example, my dear student, an example number 1. And our example said that find the dimensional formula for the kinetic energy. Now we are supposed to go and find the dimensional formula for the kinetic energy. Before you answer this question, my dear student, you are supposed to think the quantity that you have on your questions. Try to think the formula of obtaining that quantity. For instance, on the kinetic energy, we are supposed to know the formula of obtaining the kinetic energy. Now, the kinetic energy is equal to half mv square. Ni sawa na half mv square. This is the is how you can find the kinetic energy. Formula yake ni half times mv square. But this m represent the mass. but V represents the velocity. Now, after getting this formula, it is a time to see how can we find the dimension of the kinetic energy. So the dimension of the kinetic energy will be equals to mass. Now we are supposed to use the formulas to introduce the dimension on the formulas. For instance, on our formula, we have the mass times half mv square. Now we are supposed to find the dimension of the mass, also the dimension of mv of the v square, velocity. The dimension of velocity ni ngapi? Lazima tuweze kutafuta. Also on your formula tulikuwa na half, because this half is dimensionless. And if it is dimensionless, my dear student, we were supposed to find the dimension of a half. Dimension ya half itakuwa ni constant. It means in dimension, haina dimension. Kwa tutai assume ni kama 1. So we can go and see dimension of mass is m. Also dimension of velocity is LT negative 1. It is LT negative 1. This is the dimension of the velocity. But here, as you can see, a half is dimensionless. Then this dimension of the kinetic energy itakuwa ni sasa, kwa sababu ile LT ndo velocity na velocity ilikuwa inside the square. Kwa tutakachofanya tutai square e dimensions. Kwa tutakachokifanya tutapata dimension of the kinetic energy is ml square t power negative 2. Therefore, we can conclude by saying that the dimension of the kinetic energy is ml square of t power negative 2. So after there, we will conclude by saying that this is how we can explain about the dimensional analysis. So I have a task here, my dear student. You are supposed to find the dimensional formula of the force. Kwa jaribu we mwenyewe kufanya hii task, kutafuta dimensional formula of the force. So after there, my dear student, this is the end of our session. Now I would like to welcome you again for another session. I wish you all the best.